Okay, so good morning everyone. Last lecture of this period. Next week we will be having a skiing holiday, well, without the snow, but anyway. We will not be having a new set of exercises or lectures or anything like that next week. But anyway, today we still have a couple of topics to discuss, general topics which are more or less important information for any software developer or people doing maintenance. Some would say that they are crucial to have any sort of successful software project regardless of their size. So today's software maintenance course topics are version control and software product line approach. Basically things which are usual in all types of projects, and the software product line approach, which is more or less usual if we are talking about large multinational multi-product families of software. But as usual, let's start with a quick recap from last week's lecture. Last week we were talking about reverse engineering. So basically the fundamental concept of reverse engineering is that we have something that already exists, but we have lost parts of information, or we have lost access to the original source code, or something else has happened and we need to get the fundamental design for migration to new platform or new system, or understand what happens within the program. And of course, the reverse engineering comes from the idea that, of course, if we are doing forward engineering, the normal type of engineering, we go from requirements to do the analysis and design work and implement the system, whereas in the reverse engineering, we do the exact opposite. We have a artifact which does something, and based on how it responds, we try to model or redo the design, understand how it behaves, what happens, and with some tools even might be able to recreate the original source code. Of course, the translation back from the compiled code to source code isn't usually very accurate, and it loses some information, obviously, such as comments which are no longer available because that data simply does not exist in the system. It also sometimes loses the original implementation. For example, if we are working with Python, it might compile the entire thing into C program, and which means that the reverse engineering recreates a C program, which from which we need to analyze the design and the behavior of the system. Regardless of when we use reverse engineering, the problems with it are that it's very expensive, but it sometimes helps us with problems. There's a number of things that the reverse engineering is meant to be useful for. The most common case being that it helps us by recovering lost information regarding how the system behaves. If we are working with the legacy systems, this is sometimes a very important thing to do because we need to understand, for example, how the network protocols or customized network interface actually works. Of course, sometimes or many times it's much cheaper to actually recreate the entire system, but if we talk about critical or industrial systems, it's usually cheaper to just reverse engineer or redesign some part or interface if we have lost access to the original documentation. Of course, this is also a fringe case because if we talk about critical systems or highly expensive industrial automation tools, one might ask, how can we end up in a situation where we no longer have access to the source code or the documentation or the behavioral patterns or UML diagrams and such, but trust me on this, it has happened in history, and that's why reverse engineering tools have been developed as a sort of a helping hand to aid on this thing. Of course, it also helps with the maintenance work. Sometimes if we have old legacy systems, especially something that we have to work as a black box or question mark, it helps us to identify the side effects and anomalies. So if something strange keeps happening, we might want to reverse engineer or decompile the original source code to see if there's something that shouldn't be there. Of course, this is useful if we are talking about third-party systems, although there are some legal problems on doing the decompiling work on commercially available tools. So check that before you start doing anything crazy. And finally, of course, because the fundamental idea is that we get information. We get information on how the things work. It helps us in the migration process from one hardware or software platform to another. And finally, because of that, it also facilitates software reuse. So there was also talks about re-engineering, which is more or less work where we are doing redesign of something. It's a larger concept than the earlier when we were talking about the restructuring the system or refactoring source code, but the re-engineering means that we are redesigning everything from scratch or perhaps on a new platform. But this also needs the information on how the system should behave. So there's a huge overlap on the reverse engineering practices. But like mentioned, today we are going further away from the one-person activities or sort of activities which you could expect if you are doing a small software system. We are talking about two aspects today: software product lines and configuration management. And since the configuration management is more general or common theme, which all real software projects more or less use, we will start with that. So, software product management, of course, is a discipline of building, implementing, and managing the system, the entire product, the service, whatever we are working with. And of course, if we are talking about the product management, we also need to take into account the real life aspects of working with the software. So there's a life cycle, there's software ages, there's things that we need to do when the software product hits a certain age. We have to refactor things, we have to recreate things, we have to add new functionalities, we perhaps need to support new software or hardware systems. But still, the product management more or less is the normal way, describes the normal way of doing things. So find a market, find a customer, make a product, sell the product, and finally, when we are end of the life cycle, kill the product because it generates more costs than actually generates revenue. So going forward from this on the other management aspects, the product management, of course, means everything we need to do. So the configuration management, it's actually an act of establishing a consistency on the product's quality. It's within the product management work, the configuration management and software configuration management is the task where we track and control the changes that happen throughout the software lifecycle. If we are working on a one-man project, we of course always know what was changed and what was done and so on and so on. But when we have more than one people, or even one people, if we are talking about something that's really complex, we sometimes need to have the possibility to go, for example, back from a bad fix. That's a normal thing to do. Also, if we are talking about a larger product which has been sold to some customer or sold at first to somewhere and then tailored to fit the other customer, we have a problem because we have two customers which have access to the different versions of the product. So if we find a problem somewhere, how do we ensure that this problem is fixed from both versions of the product? This gets worse if we are talking about traditional software where we send or locally install something somewhere and we do not provide online accessibility or automatic updates to all versions of the system. This is fairly common still in places like industrial automation or embedded systems where we can't expect the product to have access to internet for security reasons or for complexity reasons. But anyway, we need to track which product was delivered to which customer and therefore understand which customer versions or which customer deliveries are vulnerable to this new security threat or bug or problem, whatever we encountered. So, of course, this means that we need to know what was the version that was sent, what was the version before yesterday, and so on, and more or less the configuration management is this exact work. So keeping a track record of what has been done, what has been the changes, what has been delivered to customer, what was the exact version our customer 3 years ago had, and discounting all the changes we have made for, let's say, example, for the most recent 3 years on our source code base, so that we can get and install the exact same version that our customer is using to understand or analyze or identify what's the problem and why it's doing what it's doing when or does it need fixing, or does this problem affect all the versions we have. So basically, going even further from this, the software product lines are a logical extension of this thinking. We develop products, but we do not always develop products from scratch. In fact, most of the products in most organizations are based on the earlier works or reuse components and reuse some other assets. Perhaps the most common way of thinking or the most common area of software industry where this happens are the game developers. The game developers use common engines, which more or less do most of the technical work for them. So basically, like an engine in a car, that game engine does most of the heavy lifting. It's the most complex code, most of the complex activities, animations, physics, interaction, these sort of things are handled by the engine. And if we make a new product out of that engine, we just add the new assets, the new content, the new systems, to do some tailoring work perhaps, to address the new hardware, software platforms, devices, or installation place. So this is more or less same thing as with the software product lines. It's the style of using assembly line ideology in the software engineering discipline. So we have common core components. These are the things that do the heavy lifting of the system. They are the same between the products because we have tested them. We have been using them. We have developed them several years ago, or have been testing them or doing quality assurance work on them for several iterations of the software. So we know that they are robust, reliable, and of high quality. When we get a new customer, or we have a new client, or we want to make a new product, we just make those parts which are crucial or different from the existing main line, and then package all up into a new product. Do the tailoring work necessary for the user interface, add perhaps new website front end, or some parts of it, because we don't necessarily want to do the entire front end again. Or if it's a game, add the new units, the AI logic, animations, sound effects, all the other necessary parts, so that we get a new product based on the existing core. And in general, this is meant to be a sort of a manufacturing industry thinking in software development. Because, for example, in the car industry, which is the analog I used just recently, the car engine designs have life cycle of 30 years. For example, the Renault engine, developed in the early 60s, was in production until the year 2000. Of course, it's not exactly the same engine, but it's mostly the same engine because that's a reliable and good power plant. So let's use it in cars until it becomes a too old-fashioned or too legacy system. So then we have to replace it with something else that stays up in production for 20, 25 years. So why can't we of course, there's some limitations on this in the software industry. I mean, software industry lives very rapidly and has aggressive way of going forward with the technology, but still some fundamental ideology is very sound. We create one thing that's very good, very robust, very usable, and then we can use it as our core asset on all the new products which we sell to different clients, different markets, use it in different services, different products, and only make changes to them when necessary. So these two thinking or ideologies combined, the configuration management and software production lines, we have the capability of actually making more products or cheaper products or even higher quality products or services, because we have a way of knowing which has been delivered to which customer, which is the baseline of that customer, which is the version that customer is currently using, and also have a set of core libraries which we can use as a baseline or basis for developing more products and more tailored solutions, because that's very good business practice in general in software engineering. So, considering where does this fit in our software lifecycle? Of course, the software product management, which was already mentioned first, is more or less the way of doing software products. The software configuration management is the entire thing spanning from the first proof of concept work or first lines of code which will stay in the software launch version to the final version, which is then thrown away or killed or shut down or put publicly available because it's no longer feasible economics-wise to actually keep you demanding money from it. But the software product lines are a bit different thing because they more or less require that we do sort of requirements analysis work in which we try to identify different sectors or different customer groups or different users which might be interested in using something that we can build based on our core library, or if we are a starting company, we create a core library of things which we can then expand into new sectors or new customer segments or audiences or new areas of business and different industrial domains perhaps. So basically the software product line thinking actually affects everything in the way we want to do software development. But let's start with the configuration management. Originally, this is of course from the old history of things. The original thinking was that we release something and then we sell the disk in a shop, in a box, in a store, and then, or sometimes if we are a very modern thinking company, we have a web store where you can order the box directly from us, and we do the release 1 and send it to all our customers. If we need to fix something, we do the release 1.1 and send the update disk to all our customers again. But on the other hand, if we do the second release or the second version of the system, or basically anything, there used to be a problem that we actually miss some bugs or don't use the most recent version, or because of asset reuse or branching versions, we have fixed something in one branch, and on the other branch, that same bug reappears when we do new release. Because of the bad migration process perhaps, or that we are not migrating the versions or branches from the development fast enough, or that there's simply too much incompatibility between the two branches that we can't actually do the merge activities in any same way. So of course this is a bad thing because it means that we are doing redundant work. For example, on this picture, which was taken from one book explaining how the configuration management works, this scenario would mean that the bug fix has to be done twice. And of course there's no sense in it. We did the bug fix once for the release 1, so there's really no reason why we couldn't have that bug fixed already on the release 2. But as there's usually problems, in olden times perhaps the release 1.1 and the release 2 was started before the bug was found, and the 1.1 is just some patchwork which makes the existing version of the product work, but the changes are too radical or made by another team, so the fix didn't find its way to release 2, or won't find its way before it's redone on the release 2 version. And that basically gives us the same end result. Extra work, and that's not feasible. So, of course, why this is a problem is the same thing I have been talking about when I've been teaching UML design or UML or the object-oriented design and UML diagram drawing or modeling in other courses. Software engineering is very, very complex area of work. You don't have to have very large software when you have a huge amount of variables, different things affecting each other, and subsystems which affect subsystems, which affect subsystems, and so on and so on. So if we are building a bridge or a building or a car or something like that, we have the rules of the reality set in. We know intuitively some things, like that you should have all the electrical work in a certain way, or that you should have the fuse box somewhere which it stays warm and dry, and so on and so on. But unfortunately with the software engineering there is no restriction on the size, shape, or model, or placing, or basically anything. Everything we decide to do is because we have decided to do this. Of course, if we do the design work or the architecture work or the development work or addition of new feature or fixing bugs in an uncontrolled and undirected way, that's going to be a freaking nightmare to fix or maintain or do anything with it. Because that means that there's not one person or place or tool or document which tells us what was done, when it was done, and why was it done. So that's why we need to have configuration management. So if we go to look for the definition, it says that it's the discipline comprising the tools and techniques that companies use to manage change in their software assets. Of course, this is a bit narrow-minded definition because it says that it has to be a company that uses these sort of things. I can promise you that no sane software project has ever been done with some sort of a version control system, and the version control system has to be something else than just having a shared folder on a network drive on which everyone is putting their initials before the file and then changing the names before doing a test compile. That doesn't work, because even if you manage to somehow get the workflow going, it's bound to have the problem that people are using different versions of the different files, or that at least it means that you have to do changes one by one. And that's why there's also the tools mentioned on the definition, because this also is a tool-assisted approach of working. And of course, because we live in a modern society with the software tools supporting our teamwork, software configuration management is also something that requires all the team members to use the same tools and the same repositories and use the same approaches so that the configuration management actually works. So basically, the configuration management is how you control the evolution of a software project. It means that you have the change requests, the Scrum sprint activities or list of things you need to do, or the daily planner or the daily stories from the extreme programming and such, which you want to implement. You implement those changes, you test or use the test automation to ensure that everything works, and then you can commit your code. Everything works flawlessly, and if it fails, you don't commit. If you find out that it actually kills the performance or something happens, you just take back the patch, take back the faulty fix, and try again. This is, of course, how the modern day activities happen, but this is only because we have tools and we actually have the capability of preparing for these things. Basically, the configuration management controls the evolution, meaning that we have set of objectives and we have tools which say that set how we can achieve these changes or functionalities. And this isn't exactly new information. Like everything in software engineering, the basic principle of this work was invented in the 70s, 80s. And this was actually the first standardized activity in '83. So it's basically the same age that I am. But it has been updated and updated and updated throughout the years because it's something that really needs to be done. This standardization, I'm not certain if it's available on the course website. If it's not, then Google around and see that it actually defines how the version control work or this management work, configuration management is done even in the age before internet and the network systems, because this is something that needs to be done even in a closed environment where people are exchanging information within one office or one development building. So, of course, this standardization definition is a bit world-hugging definition because it talks about good engineering practice for all software projects, phased development, rapid prototyping, ongoing maintenance, enhances the reliability and quality, so on and so on. But it still has the idea that you should consider your project or source code as a set of items. These items have versions. These versions go linearly up so that you always know which is the more recent version, which is the version you need to use. These systems, when reaching certain milestones, you select the certain versions of these smaller subsystems and define that this set of items is our current version or the baseline version. That's compiled, that's delivered to customers, that's distributed online, that's the one put on the deployment server if we are doing continuous integration or continuous deployment. And that's the version that we are going to officially support. Everything else is just work in progress version or experimental version or prototype version or whatever we want to call them, unstable perhaps or untested. But still, we design that what tools we are using to control these assets, how they are named, what are the versions that create our products which we want to give out. Of course, there's a SWBOC definition of it, like for everything else. But the SWBOC is available on the course website, so you can go check this out there. This is because this is a major thing. There's an entire configuration management part. The SWBOC 2004 was used as an example on these slides. It's a bit updated version of the version of this software engineering body of knowledge available on the course website Moodle. So go check that out. It defines the different areas, tools, and status control, auditing, and all the other things which are required for you to understand and manage and control the configuration management of your project. So going forward, like I mentioned before, you should no longer consider all the parts of your repository something that's just throwaway or stuff like that. Of course, if you are doing prototyping or rapid prototyping, then you are doing something that's something that you can throw away. But in fact, taking some ideas from the manufacturing industry, if you add a component to your system, it's a new configuration item. It can be code, it can be something, some object or existing executable third-party object. It can be a script, it can be document, it can be asset file, graphics file, 3D model, whatever it is, it's a configuration item. It's a part of your product. Like a one screw in a car engine, which keeps the idle throttle open enough so that the car engine doesn't stall, there should be some use, some reason, or some thing that the object or part or the configuration item does, which gives it the reason to exist on your repository. So considering that it can be anything, but the idea is that it's meaningful part of your product. If you find that it works faultily, it's wrong color, it doesn't load up correctly, it doesn't sound good, it doesn't work well, it's too slow, and so on and so on, then you update that part. You switch it to something that functions, replaces that functionality, but consider still it as a configuration item, which has a version number and a purpose to exist. Purpose so that it actually works. Well, on some occasions, like for example, documentation for the user or instructions on how to use things, of course, they aren't part of the critical path of your product. If you have a typing error in your manual or the instructions on how to use the old version on your manual, of course, it doesn't mean that your product can't be used at all, but still it's a faulty document. So you need to fix it at some point. And making an update on that is a perfectly fine work, and there's actually technical writers whose sole purpose of existing as a profession is to fix the documentation. If you are doing something which requires graphical assets, if you're doing a website or front-end development, you probably need to have some assets loaded from files, logos, some background, or other things which can be generated based on the view definitions. But still, those sort of things are components of your software. And when you are doing software configuration, like mentioned, you select from these configuration items a set of versions which are the baseline or the current supported and used version of your product. Like a number of Lego blocks, you select those Lego blocks and put them together into your product. And of course, the cool part of this is that if you are using version control, if you are using tools which support all the necessary activities, you know for the rest of the life cycle of the product which versions of the files were used in which build. So you achieve the functionality that if you sell your product to a customer, you know which version of the product was delivered there, which is used in that location, which is used on that location. And for example, if you expanded the product lines, what version of the system or the core components are used in that product, what is used on that other product, and perhaps sometimes upgrade them if necessary. So of course, this means that there's bound to be versions and variants of your product. If we are talking about the versions, it of course means that they are the line of succession product versions, meaning that the successor should be always better than the predecessor version, and there should be a record on what was actually changed. This is the typical or normal way of doing software maintenance and development and enhancements. You add features, you add functionalities, you enhance quality, you enhance performance, you enhance the support of new platforms and software. But of course, you are bound to have variants, which means that in some industries you need to sell the different versions to different places, or you set the core components to certain version of the product when you sell it to your customer or release it as a product, and your next product might actually use the newer version of those core components, but the variant which was sold to one customer doesn't necessarily get the upgrades, the same upgrades that those customers who bought the more recent version. And this of course means that you have to support the different systems, but of course that's just normal software business and software life cycle. So the important 4 things are the support for branching, support for build, support for release, and support for knowing what's the delta, meaning that the difference between the different versions. Of course, if we go into the modern software development like DevOps or continuous deployment, there's this ideology that the branching is unnecessary work. If you do branching, you have one extra project, so you should avoid doing that. But on some industries or some products, you are bound to have different variants simply because your customers are paying for different sets of features. And that's completely valid reason why you should have a variant of your product. If you have different levels for customers or different price tags for different usages of your product, then you need to have the variant support, because you will run into a situation where you need to fix something from all the versions, and in situations when you need to just fix one variant which uses the feature which is affected by the bug or security vulnerability you just found out. So basically you need to have a couple of important informations. The build, so what was the combination of the components used on the certain builds? What is the release version, the most current version of the version the customer uses? And what's the delta between one build to another? So that you can compare, for example, the different variants or different differences between something, especially if you are backtracking on issue, so that you can find out the place where it happened originally. And this means that you will have a baseline version, or basically several of them. The baseline version isn't anything magical. It isn't something that's dictated and the king of software engineering comes in and declares your product to be a baseline version starting today. It's just a decision that this version is formally reviewed. This has passed our quality control, and this is the version of the software that we at this point consider to be of high enough quality. All the different things we have been talking about on the earlier lectures. If we have this sort of version, then it can be decided that this is the baseline. So we will not go further back behind this version. This is the one on which we will base all our future changes. Because this makes it easier for you to work, and this makes it easier for you to cut the unnecessary branches away from your source code repository. All the future changes are based on version 1.000, which is composed of these components and these versions of these components. And this is just a decision, but this also means that you need to have the capability of identifying when your product is of high enough quality, fulfills all the current requirements, and is stable enough so that you can use it feasibly. If you select a baseline version which does something crazy or isn't stable, you will be again and again and again fixing the problems caused by unfinished core systems or core functions, and that's going to be a very bad situation in the long run. So, okay, this definition about what the baseline is and what it does comes, for example, from the Rational Unified Process, which is an IBM way of defining all the different possible ways of doing software development. Of course, it's more or less the snapshot that this is our main version. It has new features. It's distinct from our earlier baseline. It has new features. It has certain modernizations. It has support for new platforms, like added support for mobile devices, which was the craze a couple of years ago, well, 10 years ago, when the mobile devices finally became powerful enough to run any software. And of course, the baseline is the version from which all the subsequent work is done. And of course, the reasons why these are created are that they increase the reproducibility, traceability, and reporting capability of your product. So you are comparing against the most recent baseline and not against something that was made in history. And of course, baselines should be created at the end of the major iterations. Of course, with the DevOps and continuous integration, continuous deployment, the iterations can be really short, so not everything can be a baseline all the time. But for example, if you reach some major goal or major new functionality or activity, that might be a good idea to keep as your baseline version, because that means that if you are creating a new product, you can start based on that because it works. It has the necessary functions, and it has new features which we know have tested that they function correctly. So there's a couple of best practices for the configuration management, like for everything else. So identify in a secure repository. This, of course, can be that you are using a GitHub or something like that. Of course, it means that if you are trying to do configuration management, it would be wise if it's stored somewhere where you don't lose the entire system and the system hit and the software history where if something stupid happens. So create baselines and milestones, record and track requests for changes, organize the versioned artifacts into versioned components, and so on and so on. Pretty fundamental aspects. The list continues, integrate all the and merge unnecessary branches. If you create a new feature on a separate branch, you should probably merge it as soon as possible, because if you are working on the different branches, you might have a problem if you are branching into too many directions. So try to keep one trunk line going, and if you are doing something experimental, do a temporary branching based on that. And if it works, when it works, immediately merge it back, because maintaining several branches of your product, of course, means that you are having to do the maintenance work several times over. There's also studies indicating that having a trunk line development, meaning that there's little to no branching ever, is actually fairly powerful and very straightforward and efficient way of doing software development. But of course, this means that if your trunk or the only one branch approach fails, it has a bad patch, you can turn back or go back on the versions so that you can do experiments on the main version, and if it works, then you deploy it. If it doesn't, then you just scrap it and start that iteration over. So of course, there's a couple of small things you need to understand. Of course, the software, the system or entity which you might want to call a major release or the baseline release, of course, it's based on a huge number of systems, subsystems, components, things communicating to each other. So therefore, you need to do this some other way than by hand. Of course, that's more of a gimme, but still I see there's a couple of years ago I was doing interviews on organizations and their software quality control, software quality management practices. And for some reason, they still decided that the best way of doing things was on using Excel sheets and files on network drive. Don't be that organization. Try to use tools because they are very good at doing configuration management. And that means that they facilitate and automate all the version control work, the delta work, understanding the differences, making your system a freezed, separate major releases so that you can go back into certain version of the software whenever you want to. There's several different ways of doing this. I'm not going to say anything about what's the right way of doing or what's the right tool to do this, because there's a different schools for if it's a Bugzilla or Mantis or Git or Subversion or whatever IBM tools, which are otherwise fine but tend to be fairly extensive and expensive. Also, web collaborative tools, several different ways of doing this. So pick one and use that on that project. That's more or less the best way of doing things. And of course, there's free versions, but if you are doing commercial software development, you might want to have something that has access control and some other features which enable you to work. So this week's exercise is about this version control tools, so you can check them out when you are doing the exercise work. There's a couple of basic functionalities on basically all of them. Create, store multiple versions of the files, maintain library or repository, identify collection of file versions and make a release version out of them, and so on and so on. So the idea is that basically everyone always gets the new version, and there's merging and migration of the changes so that you actually get to see and get to have the new functionalities every time someone in your team does activities or commits code to the system. But of course, these are only tools. You need to sometimes have people who make these decisions and controls how the software is developed. An easy example of this is that, of course, you are the project manager. You have the tools to do different versions. You have the power of designing what's the baseline version and what's the major release, what's not. But still, it doesn't mean that the automation makes everything work flawlessly. I have been in talks with people who went to an important business meeting with the most recent prototype of their tool or game or product or service or whatever. They went to the showroom, started the project, and it failed spectacularly. Simply because there was no control on what was going on. So there were some people doing some changes during the feature freeze meaning that the most recent source code doesn't actually compile or work. So that's also the reason you need to control these things. If you have something, if you need to have a functional system, you need to have a feature freeze version somewhere, or if you are showing off live version of the product, have some control over when it's okay to do changes. And this is something that's usually done by a configuration manager. It's not a separate person in most projects, but it's someone who has the access to the tools, has access to the versions, has access to creating the infrastructure, and actually ensures that your system works. And that person also is the one who ensures that you have, for example, the most recent stable build stored somewhere. So if you are going to your client, you can show that your demo version or your demo environment or your demo site is always functional, and the person responsible for ensuring that the unstable, untested, experimental, and build and in production versions don't accidentally mix together. So so if the architect is the one doing more or less the architecture work, the configuration manager is, or person doing the configuration manager's work is the one who actually ensures that your system works and you have the functional daily build or the functional build always available. So based on this information, so that we can have separate development versions or separate versions of the artifacts or configuration items from which we create our software, we can extend our business considerations a bit, going into software production lines or product lines. So basically, now that we have the capability of reusing our assets or reusing our subsystems or releasing them at several times on different versions, we can consider the software product line as a set of software-intensive systems which share a common managed set of features. This means, of course, that we can create several products out of the same components by making some small adjustments to our customer base, to our new customer segment, to our new business domain or business segment, or our new requirements. This also means that we don't necessarily need to add the new feature for all users. If we have one industry, one product, or one area in which we more or less know that our customers want to use this, or we don't have access to our customer system for any reason, if we want to resell our product or repackage it so that it's actually available for other people to purchase, or has small feature changes so that it can be sold to a certain customer, we can do a product line approach and make a small tailoring work so that the core assets create the software and the tailored components are just ensuring that we have a new product to sell. So basically, this is more or less the ideology where we have business goals or new products or services made out of existing parts to a certain degree. So we have commonality advantages. We have products or services which share the basic functionalities between each others, but they are distinct, different products. Like in car industry, if you drive a Volkswagen or Skoda or Seat car from the same year, from the same target audience, you quickly notice that they are in fact more or less the same car with 3 different badges and small changes here and there. One of them is more sporty thing, one of them is more family oriented, one is more neutral but has this sort of has a small set of features which makes it more attractive to businessmen or people who need to do business traveling, for example. They all share the same common core assets, but they have their own business goals, they have their own target audiences, and they have been tailored to match those audiences more closely than having one common car which is sold to everyone. So we try to have variability based on our common core assets so that we can reach our target audiences better or cater to our different customer groups or customer segments more closely. This also is achieved by economy of scope because it's not always wise to recreate everything from scratch. So you will, when the visiting lecturer I talked with and who is coming next period to talk here, talked to me that everything is basically reuse. But the software product line doesn't mean reuse of components. It's not just one component or one baseline which is used, or just one configuration, or one standardization, or something like that. Of course, if we want to reuse software or assets from our previous products, that's of course understandable, and that's a good way of recycling or products or avoiding doing unnecessary duplicate work. But the software product line approach is a bit more than that. It's basically strategic reuse, meaning that it includes the idea that we have to maintain a core libraries, set of core libraries which ensure that we have certain functionalities, certain set of features, and then the products are based on that set of features. For example, if we were a game studio, we would probably have the core features as our game engine. If it's developed by us, then it could be also something that we maintain and extend throughout the time, whereas our products are just the new assets on top of the core libraries, making them a new product. So basically, the idea is that we use the core asset base in production of related set of products. So we make new things for new target audiences based on the existing blocks or tools we already have. It locks down in a way that we have basically two sides of software development in our library. Sometimes we want to develop the core assets to add new features or functionalities or support for new platform for them. Sometimes we do product development, which is more or less the same thing we always do in software engineering, but this time we start with a set of core assets. And the third wheel, management, means that we have prototypes or test runs or trials trying to identify new products or target audiences or services we could create based on our core assets. So we have core asset development, product development, and so more or less the business development or business tryouts or business-based management as our three types of software projects. Of course, the core asset development is not that difficult. I mean, if we have core assets and we need to update them, maintain them, then we just do the design what needs to be changed or what needs to be added, make the changes, add those assets to our library, and use those assets in our products. If we do software development, then we just take the core assets, use them in our product, and create new products out of them. We get feedback from our customers, we get constraints on our end products, we get new assets which could be promoted to our core library. based on the information on these development projects. This also gives us feedback on what type of core asset development we need to do later on, because we see in practice what still works and what needs revisioning. Finally, in the management cycle, we do all more or less all these things, but the management aspect here is to actually try to find new areas in which or new domains or new business areas in which we could create new products, or try to find funding or money or time or resources to do the development work for the new core assets. So basically, this is more or less the division of work if we consider our approach into software development from the viewpoint of software product lines. So we have software engineering work, we have technical management work, organizational management work, and these are basically deployed into either the development of the core assets, the development of new products or services, of course, because software industry is going towards the service-based industry, or management cycles in which we can also consider something like developing a business case, developing a throwaway proof of concept, trying to find new funding, trying to find new partners or organizations or customers or clients, and these sort of activities, which are, of course, a bit boring thing from the or that necessary evil thing from the marketing and business, but unfortunately thing that we have to do if we are running a real software company selling real software solutions. So of course, there's some costs associated with it. The architecture might be a bit different than what we already have. The software components and their upkeep and maintenance, it's a bit double-edged sword, because of course maintaining core components in a situations or upgrading them might be considered a bit of unnecessary work by someone who doesn't really get this ideology. But still, even though it doesn't create new product, it's still something that's important. Of course, if we are maintaining our software as a product line, it means that we have new test plans, new test cases, and new test data based on the different variants which are out on the field. But this is more or less something that we have to struggle with in any case, because we more or less probably have different versions for different clients unless we are doing one trunk development DevOps approach. Of course, other things, project planning, tools and processes, people skills and training cost money regardless. So it's just that you need to adjust your approach to this functionality, this way of doing things. And if it's done correctly, it probably gives you some benefits. Of course, the productivity and quality goes up, and cost and the labor needs go down is something that all the different models and approaches or processes promise. But there is actually two important things mentioned here in addition of the marketing speech mentioned here. For example, time to market is something that's really important. If you are not the first company to come up with something, you more or less have to be the second or third company to reach the market so that you actually make some money out of it. And of course, if you have the capability of testing out new products which might be interesting to new customers, you might sometimes be the first to market, so you make more money. If you start with existing core components and only need to do the tailoring work of the front end or the user interface or the some content additions, you reach the market, then you probably are far ahead of those competitors who have to create everything from scratch. And this gives you the ability to move into new markets, which by itself is a meaningful thing, because if you just come up with a business case that we could use this product or this system, if we configure or create this out of it, we can sell this to a new market or these clients or in this country or in this area. And it's of course going to be a huge thing to have. And finally, like with the test automation, there is a payoff point when you have enough products or enough domains or enough areas in which you use your core components. Of course, this means that you can't have everything as your core component, because that would be stupidity, or at least it would be against the ideology of product line thinking. But considering that you save time, you save money, you save effort on quality assurance and testing work when you know that certain part of your product already works well and doesn't have surprises in it, you will have a payoff point somewhere, especially considering that if you need to make everything from scratch. So, in summary, the product line concept is more about managing the assets. If you do configuration management, you have components or parts. These parts can be packaged or defined that this is a stable core asset, or this is something, a subsystem that works very well. So if you use it as a core, you can then add, use these core components to provide you abilities or functionalities from which you can base your new products on, like in the manufacturing industry. So the configuration management enables you to also do product line approach into developing software, and this is something that's fairly important if you want to do or run or work in a large software organization, because all of software organizations do this to a certain degree. So, if there's nothing else you will want to remember from this lecture, remember the basic concepts of configuration management and what the product line approach is. You don't have to be able to draw them out of memory, but if you understand what configuration management is and how these tools enable you to do that, this is also something that you are expected to do in the exercises, then you understand why it's a wise thing to do and why you almost always want to have a repository for your code. If you end up working in a larger organization or something that enables you to do product line approach, in the long run you will probably save money and you will probably have easier times getting your new products out of the door and have faster development cycles. Finally, like mentioned at the start, next week is an exam week, so no lectures, no video, no exercises, no consultation hour either, and I will be having a vacation, so don't bother sending email. If it's something very urgent, then I might answer you, but this is in a situation where the 112 emergency number doesn't answer, so then try calling me. Finally, deadlines are always before the next week lecture, the next lecture, so this means that this week's exercises you will have 2 weeks to complete them, because next lecture will be in 2 weeks on Monday. So that's that. The first period is now done. First set of 7 weeks is done. Have a nice holiday if you have one. Have a nice exam week if you have one. And we'll be seeing back in 2 weeks. Thank you.